Very good morning, my dear students. So I think in the last class, we have just discussed two important derivations regarding the volumetric strain in a rectangular bar. And the second one is the relationship existing between the modulus of elasticity and the modulus of rigidity, right? So I think we done with the things. If you have any clarification, you can have now. Okay, before just proceed for the next thing, there is another one last topic that what we're going to discuss in under module 1. Okay, after this we will need to solve some problems. That's why I just put please have calculators today. So because I will going to be we're going to solve some numerical problems today also, because the derivation takes around hardly around 10 to 15 minutes. So afterwards definitely we will be having numerical problems. Okay, I hope everybody is having a pen, paper and calculators with you. Okay, yeah, so I think in the last class we just started with establishing a relationship between the modulus of elasticity and the modulus of rigidity. So at the end we have arrived at then relationship which is nothing but E is equal to 2 into G of 1 plus nu, right? This is where E is the modulus of elasticity and G is the modulus of rigidity and nu is the Poisson's ratio. This was the expression what we derived in the last class. Okay, so today we will just continue with another one relationship, that is a relationship existing between the modulus of elasticity and the bulk modulus. Okay, and later at the end we will going to discuss, or we will going to establish the relationship between the modulus of elasticity, modulus of rigidity and the modulus of bulk modulus. All these three elastic moduli, how they have been related. So this is what we're going to do it in today's class. And if you complete this, I think we will be completing the theoretical concept of all the contents in the module 1. Okay, so afterwards I will going to have numerical problems, 1 or 2 problems if possible. We're going to solve it today, and the rest of things we're going to continue in the further classes, right? So now I think in the last class yeah, so this was the expression what we have derived in the last class, right? So in today's class, let us just continue. It is the assignment also we had, the relationship between E, K and nu, modulus of elasticity, bulk modulus and the Poisson's ratio. So for this, first what we will going to do here is, let us take a cube subjected to a stresses which are equal in magnitude in all the 3 directions. Okay, so x, y and z directions, the cube is subjected for a stresses whose magnitude is equal to sigma. Okay, so in that case, so if you want to calculate what is, if I want to use, or if I want to calculate what is the strain along x direction, okay, and strain along y direction and strain along z direction. So this is what we are supposed to do it here. So for that, what we can do here is, so I think in the last class we have derived one, we are arrived at one equation. So volumetric strain is equal to epsilon x plus epsilon y plus epsilon z by E into 1 minus 2 mu. So if you're making use of this expression over here, so when we use this expression volumetric strain, so which is equal to sigma x plus sigma y plus sigma z divided by E into 1 plus 1 minus 2 nu. And in this case, what we will do, we will go into substitute sigma x, sigma y and sigma z is equal to sigma. Okay, so when you substitute that value over there, so we will have, so we will going to substitute the value of sigma x, sigma y and sigma z is equal to sigma. Then this numerator term will become 3 times sigma. Am I right? So we are substituting sigma x, sigma y and sigma z. So as already shown the diagram over there, the cube is subjected for a stresses in all the 3 directions and whose magnitude is equal to sigma. So now if I use this expression and if I substitute sigma x, sigma y, sigma z as sigma, so the numerator term will become 3 times sigma. 3 times sigma divided by E into 1 minus 2 nu. So this is a one important thing what we will going to write it first here. See, this is the expression what we have got over directly over here. So you can see here, since the volumetric strain is 3 times the linear strain. Okay, so we can get it is volumetric strain is equal to 3 times sigma by E into 1 minus 2 nu. Am I right? So now, from the definition of bulk modulus, so when we defined what is bulk modulus, it is the ratio of a volumetric stress to the volumetric strain. Am I right? So now from the definition of bulk modulus, if I write an expression, so what expression we have got for a bulk modulus, which is K is equal to sigma divided by epsilon V. Am I right? So now using that expression, and if I rearrange the terms and if I write an expression for a volumetric strain from that expression, so volumetric strain will be equal to sigma divided by K. Or K is equal to sigma by epsilon V, or we can say epsilon V is equal to sigma divided by K. Okay, so from these two equations, when you just observe these two equations here, so this equation is volumetric strain epsilon V is equal to 3 sigma by E into 1 minus 2 nu. And from the definition of bulk modulus, we can say volumetric strain is equal to volumetric stress divided by the bulk modulus. So now equating these two equations now, so on the LHS side, we will have this term which is 3 sigma by E into 1 minus 2 nu. And on the RHS side, we will going to get sigma by K. So just equating these two terms, these two equations, so we will going to get this expression. From this, sigma will going to get cancelled, and rearranging the terms over here, so we can say E is equal to 3K into 1 minus 2 nu. So you can see this expression over here. Okay, E is equal to 3K into 1 minus 2 nu. So this is the relationship existing between E, K and nu. Very, 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 very important is this. Okay, see, in the examination, sometimes they will go into ask establish a relationship between E, K and nu. Okay, if they ask for 8 marks, if you write this much, definitely you won't get 8 marks. So why I'm telling you, because so this carries only around 3 steps. So for 3 steps, they don't give 8 marks. So if it is asked for 8 marks, they'll be expecting another one derivation, which previously what I told. So that is, sorry. Yeah, this derivation you have to show. You have to show this, you have to show that, and you have to prove that epsilon V is equal to sigma x, sigma y, sigma z divided by E into 1 minus 2 nu. And later you have to substitute sigma x, sigma y, sigma z as sigma. And then from there you have to continue with these things. Please be careful. Depending upon how much marks they have asked, so we have to do that. Okay. So if it is asked for only 2 marks or 3 marks, just establish, this is enough. If they ask for 8 marks, so you have to get that expression, that is volumetric strain is equal to sigma x plus sigma y plus sigma z divided by E into 1 minus 2 nu. So that expression you have to derive, and later part, so since the stresses are equal to the magnitude sigma, so then we will going to get this expression. From that you have to get this expression, and later part, so you have to continue with the things what we discussed right now. Is it clear, my dear students? So please be careful. So if they ask for 8 marks and if you write only 2 lines or 2 steps, definitely you won't get 8 marks. Isn't it? So now this is the relationship existing between the modulus of elasticity, bulk modulus, and the Poisson's ratio, which is equal to E is equal to 3K into 1 minus 2 nu. Very important relationship between E, K, and nu. Is it clear? Any clarification with anybody? Anybody having any doubts in this regard? So you can ask here, because this is very important derivation from the examination point of view. Yeah. Anybody is having any clarification in the relationship between E, K, and nu? Kritik N. Kritik N.
Yes, sir.
Yeah, could you able to understand if you have any clarification?
Yes, sir. No, sir. No, sir.
Okay, right. Chetan Kumar,
Yes, sir.
could you able to understand?
Yes, sir. Yes, sir.
Right. Yeah. Rahul Rathod,
Yes, sir.
could you able to understand?
Yes, sir. Understood, sir.
All right. Yeah, anybody is having clarification with this? You can. Before I proceed to the last concept in this module 1. Okay, so if nobody has having any doubts, so I will go move on to the last derivation, that is a relationship existing between E, G and K. E, G and K. So we have established relationship between E, G, nu. Now we established relationship between E, K, nu. Now the last thing what it is left out is the relationship existing between E, G and K. So how we can go have it? Yeah, so this is a very simple derivation. I think you can easily do this. So we have E is equal to 2G into 1 plus nu. Am I right? So from this, we will going to write an expression for nu. We will going to express nu in terms of E and G. So this is the expression what you will going to get. It is 1 minus 2G divided by 2G. Okay, and similarly we have a relationship between E, K and nu. Am I right? So E is equal to 3K into 1 minus 2 nu. This you know. So now from which we will going to write an expression for a nu again. Nu as nu is equal to 3K minus E divided by 6K. 3K minus E divided by 6K. So this is the one what we have obtained from the previous two relationships what we have established. So in both the cases, so nu, we will going to write an expression for a nu making use of those two expressions, and now we will going to equate these two now. Okay, so only the RHS portion will be equated, and we will going to express what is the relationship between E, G, K, right? So now equating these two, so now we will going to get, so after simplification and everything, so we will going to get E is equal to 9GK divided by 3K plus G. So please remember this expression. So the relationship between E, G and K. E, G and K is E is equal to 9GK divided by 3K plus G. So this is the relationship is having between E, G and K. Is it right? Would you able to understand this? How we can get this relationship? Just writing an expression for a Poisson's ratio, that is nu, from those two established relationship, and equating and rearranging. That's it. Rearranging the terms over there, and we will going to get an expression for E, which is equal to 9GK divided by 3K plus G. Is it right, my dear students? Could you able to understand this? Could you able to get this? So if everything is understood, I think that's is the module 1. Only thing is the concepts have been completed. Only thing left out with the numerical problems. Anything to ask over here? You can ask. So before I just start with the numerical problems over here. Any clarification, anybody? Yeah, anybody is having any clarification, my dear students? Otherwise, I will start solving a problem today. Shall I proceed?
Yes, sir.
Okay, so please have a sheet of paper, pen, and calculator with you. So why I'm telling you this is, so understanding the concept is different and application of the concept is different. So till now, we were just understanding the basic concepts of mechanics of materials, right? Now, we need to apply this concept of mechanics of materials to the real life problems. Okay, so the real life problems will always is a challenging task for you. So because a lot of thinking will be left and you will be there and you should decide which concept I need to apply and which formula is appropriate for that particular situation. There are plenty of things, plenty of decision has to be made under this analysis in application. So therefore, so hoping you people understood the basic concepts of mechanics of materials in the module 1. Okay, so I will take you for solving the problems because I told you at the beginning almost 70 to 70% of your marks in the examination will carry numerical marks, numerical problems. So only the theoretical concept may be around 20 to 25%, and remaining all marks out of 100 marks or maybe around 70 to 75 marks is numerical problems only. So therefore, we had to give more prominence for numerical problems because variety of problems are there. Plenty of varieties of problems are there. So you should think and you should know which concept I need to apply here and how I can get the correct solution for that particular problem. Is it right, my dear students? Shall I proceed? Shall we start with the numerical problems today? No answer. Bhavana?
Yes, sir.
Shall I start? Shall we start numerical problems today?
Yes, sir.
Right. So please have a sheet of paper, pen, and calculator with you. Okay, I want you people to solve this on a paper and keep it with you because this is very, very, very important. I'm telling you. So whatever theory concept, it is only a few marks from appears from this. But now onwards, what we're going to do, it is the majority of the marks is on problems. Okay, so please try to involve in solving the problems in mechanics of materials. Okay, let us start with the first problem. I want everybody to note down this problem. Yeah, please make a note of this problem. The following data refers to a mild steel specimen tested in a laboratory. The following data refers to a mild steel specimen tested in a laboratory. The data is as follows. Diameter of the specimen 25 millimeters. Length of the specimen 300 millimeter. Extension under a load of 15 kilonewton. Extension under a load of 15 kilonewton is 0.045 millimeter. 0.045 millimeter. Okay, then load at yield point. Load at yield point is 127.65 kilonewton. 127.65 kilonewton. Then maximum load 208.6 kilonewton. 208.6 kilonewton. Then length of the specimen after failure, 375 millimeter. Neck diameter 17.75 millimeter. Seventeen 17.75 millimeter. Yeah. Determine Engs modulus second one, yield stress third one, ultimate stress, fourth one, percentage elongation, fifth one, percentage reduction in area, and the last one, safe or permissible stress. Adopting a factor of safety of 2. So this is the problem. Okay. So this problem, if I look at the data what they have provided, it is a data pertaining to a tensile test conducted on a mild steel specimen. So I think when we have discussed the stress strain diagram or a stress strain curve for a mild steel material, so which is under tensile loading. So I think this some of the terms I think you can see here, yield point or maximum load or neck, all those things you might have been heard. So this is that's where we have discussed the stress strain diagram. It is basically to understanding the behavior of the material when it is been subjected for a tensile, right? So here the data is given. So in the sense at particular point they have measured the data, and that the data has been given, and they are asking us to determine some of the things like modulus of elasticity, yield stress, ultimate stress, or percentage elongation or reduction in area, and safe or permissible stress. So this is what you will going to do it in your laboratory also when you conduct a material testing laboratory. So when you conduct a tensile test, so you will have all these things over here. Okay. So now see generally how we proceed the problem for getting the solution. See basically this problem is for 10 marks in your examination. Simplest of the simplest problems what you will have it in module 1. All right. So this problem, so first what we generally do is we just note down the data with the corresponding annotations, and later we make use of the formula to calculate whatever the things they have been asked for, right? So let us start with the diameter of the specimen. It means that this is the initial diameter or the original diameter of the specimen. We generally take it as di. Okay, d suffix I. So I think we can see in the next one d suffix o, anything you can take. So original or initial, d suffix o is 25 millimeter. The final diameter d suffix f, it is 17.75 millimeter. Original length is 300 millimeter. Final length is 375 millimeter. And he has given another one data. See, at the extension at a load of 15 kilonewton. In the sense, when you start loading the specimen and at a 15 kilonewton, when the load has reached the value of 15 kilonewton, correspondingly the deformation or the extension is equal to 0.045 millimeter. So means this value of extension is at a load of 15 kilonewton. Okay, please remember this, right? So delta L is 0.045 millimeter at 15 kilonewton, and then they have given the load at yield point as 127.65. So we can say Fy. Okay, then FRP, anything you can take. Maximum load they have given, it is 208.65, that we can take it, no problem. Next thing is the length of the specimen after failure. Length of the specimen after failure, in the sense final length we can call it as, it is 375 millimeter. Neck diameter, that is the diameter of at the neck. So we will take final diameter, because final diameter is not given here. We will take it as a neck diameter as the final diameter, which is equal to 17.75 millimeter. So be careful with the units over here. Okay, everything is in millimeter, nothing to worry. If they change the units to centimeters and meters, so be careful converting it into everything into millimeters and solve the problem. Okay, is it okay with the data? Anybody have any clarification, any doubts in the clarification of the data, problem data?
No, sir.
Right. Now, how we can solve this problem? One by one, we will go to take it out. So, Engs modulus. So, how we define Engs modulus? So, it is the ratio of stress by strain. Am I right? So, modulus of elasticity or Engs modulus is the ratio of stress by strain. So, now to calculate value of E, we need to know what is the value of a stress and a strain. Let us take now stress. How to calculate stress? It is the load divided by the cross-sectional area. Am I right? Load divided by the cross-sectional area. So stress sigma is equal to P by A. So what is the P we will go to consider here? So since the extension is given for a 15 kilonewton over here, okay, so because at this point only you can get the deformation, and from the deformation you can calculate the strain. So therefore 15 kilonewton will be considered as the load over here. That load divided by the cross-sectional area. So it is a diameter of the specimen is 25 millimeter, and hence we will going to calculate the cross-sectional area as pi by 4 into d naught square. Using that, we will going to see the initial cross-sectional area of the specimen, pi by d naught square by 4. So d naught is 25 millimeter, pi by 4 is equal to 490.87 millimeter square. Please do on your paper, and please try to don't simply copy down the values. I want you people to do it on your calculator, because this problem carries 10 marks in your examination. Simply just substituting and copying the values definitely won't fetch you anything. Why I am telling you here, in mechanics of materials, the final answer will count. If you have substituted, if you have written the formula, if I substituted all the values correctly, but the final answer is wrong, means so you will get 0 out of 10. Be careful. So that's why you should practice. You should know how to operate your calculators correctly, and you should get the values correctly. Otherwise, think that you are getting 0 out of 10. Be careful. So that's why I'll insist you people to practice this with your calculator and operate the calculators correctly. Okay. So pi into 25 square by 4 is equal to 490.87 millimeter square. This is the initial cross-sectional area what we have. Okay. Then moving on to the stress. Okay. So sigma is equal to P by A, which is equal to 15 in 10 power 3. Load is 15, 490.87 is 90.87 is not there. So you can put 490.87 and get me the value of the stress, which is equal to 30.55 Newton per millimeter square. Please do that. So how much exactly, what answer you are getting, please tell me. 15 in 10 power 3 divided by 490.87.
30.57.
30.55 we are getting.
I got 57, sir.
Oh, yeah. 15 into 10 power 3 divided by 490.87. You get 30.55. Check. 30.557. Anybody? Anybody has done this problem? Please tell me how much you are getting. Somesh?
Sir, actually the area I have got is 490.625. And here area is 490.87.
Okay, okay.
3.14 I have substituted.
Okay.
I got 490.625.
Oh, okay, okay. That's what. See, if you substitute 3.14, so if you take complete till the final decimal point, I think it may get up to around how much we have got? 490.87. Please check that one. Pi into d square divided by 4. It is 490.87. You will get it. Don't substitute only 3.14. Type pi value, complete value you're going to use, no? Type that, you will going to get 490.87. Yeah. Somesh, are you there?
Yes, sir.
Yeah, how much you are getting, Somesh?
Sir, by taking pi, I got 490.87.
Okay, what about stress value?
Sir, stress before I had got is stress. Yeah, stress is 30.57, but now it is 30.55.
Yeah. So be careful, okay? When you're substituting the value of pi, you take complete 3.14 something till the final decimal point. What you will get completely, you take. This is the 490.87, and the stress value, it is 15 10 to 10 power 3 divided by 490.87. You're going to get 30.55. Okay. Hope everybody got this. See, you have to practice. I'm telling you. If you don't practice, definitely you don't learn. You never know where the mistakes you are doing. When you start operating, you will learn and you will know where the mistakes are doing, and the same thing you don't do it in the examination. Okay, it is not for me you are doing, it is for you. Please keep it in your mind. Okay. Next, once you get a stress value, then let us move on to calculate a strain. So strain is epsilon is equal to dl by L. So delta L, what they have given, it is 0.45 millimeter at 15 kilonewton. So therefore, we have calculated stress also with respect to 15 kilonewton and strain also with respect to 15 kilonewton. So to calculate strain, we require a deformation or the extension, which is given as 0.045. Okay. So now 0.045 divided by its original length, which is equal to 300. So you will going to get 1.4 into 1.5 into 10 power minus 4. Am I right? So please check. Please check with your calculator. Operate the calculator and tell me.
Yes,
It is
sir.
1.4
into 10 to the power minus 4.
Minus 4. So strain does not have any units. Only it will be the value. That's it. Okay. So please write the units also. Units will also very important in the mechanics of materials. So once you get the value of a stress and a strain, the next thing is to calculate the Engs modulus. Engs modulus E is equal to sigma by E. Sigma by epsilon. So sigma value we have got 30.55 Okay, and epsilon, that is strain, is 1.4 into 10 power minus 4. So now just substitute the values and get the value of modulus of elasticity E. You just check that value what you are getting is correct or wrong. 30.55 divided by 1.5 to the power of minus 4. Check if you are getting 203.66 into 10 power 3.
Yes, sir.
Yeah, 203.66 into 10 power 3 Newton per millimeter square. That is the unit for the modulus of elasticity. Is it clear, my dear students? Please try. Ashit Kumar. Ashit.
Yes, sir.
Yeah. Are you doing the problem?
Yes, sir.
Could you able to get that value of modulus of elasticity E?
Yes, sir.
Okay. Yes. It is 203.66 into 10 power 3 Newton per millimeter square. So once you got modulus of elasticity, next thing what they asked is yield stress. So yield stress is sigma y, which is the load at yield point divided by the original cross-sectional area. Load at yield point divided by the original cross-sectional area. So the load at yield point what they have given, it is 127.65. 127.65 kilonewtons. So now substituting load at yield point as 127.65 into 10 power 3 and the original cross-sectional area is 490.87 only. So please check the yield stress value, we are getting 260.04. 127.65 divided by 490.87. Yeah. Could you able to get 260.04?
Yes, sir.
260.04 Newton per millimeter square. This is the yield stress. So please, everybody, if you are not getting the answer correctly, please stop me and you can clarify your doubts. Okay. Next, once you have got this value, the next thing is the ultimate stress value. Ultimate stress value. What is this ultimate stress value? Is nothing but the maximum load by the original cross-sectional area. Maximum load is given as 208.6 kilonewton and original area 490.87. So substitute 208.6 into 10 power 3. So 10 power 3 because you are using kilonewton. Okay, kilo comes 10 power 3. Please be careful. Divided by 490.87. So please check the value as 427.95.
Sir, 424.9597.
424.95. Okay, you can keep it for 2 decimal place, not an issue. 424.95. You can stop at that point, not an issue. Everybody got it, this answer? If you have anybody doubts or if you could not able to get this answer correctly, please, you can interrupt me. Okay. Next, the percentage elongation. They ask for percentage elongation. So percentage elongation is nothing but the change in the length. The final length minus initial length divided by the initial length. Percentage elongation and percentage reduction in area both will give you a property of a material called ductility. Please remember this. So how do you measure ductility? Means ductility is measured by 2 parameters. One is by percentage elongation, another one is percentage reduction in area. Okay, so both the parameters we are finding out here. So how to calculate percentage elongation, which is nothing but the final length minus initial length divided by the initial length into 100, since it is a percentage elongation. So final length is given 375, initial length is 300 divided by 300 into 100, which is you are going to get it as 25%. Please check whether you are getting 25% correctly. We're getting 25%.
Yes, sir.
Right. Next, percentage reduction in area. So when you get the value of percentage reduction in area, we need to get the final area. So final cross-sectional area of the specimen AF is equal to pi into df square by 4. So df is the neck diameter what they have given. It is 17.75 square divided by 4. So you will going to get 247.44 millimeters square. This is the final cross-sectional area of the specimen. Okay. So once you get this value, now you can calculate what is the percentage reduction in area. So percentage reduction in area is nothing but the initial area minus final area divided by the initial area. Initial area minus final area divided by the initial area. Since the length is increasing, its diameter is decreasing. Okay, so initial diameter was 25. Now the final diameter has become 17.75. So the cross-sectional area is also decreasing over here. So therefore, substitute the values of initial area and the final area in this expression, and you will go to get 49.59%. Please check these answers whether you are getting correctly or not. Got it, my dear students? 49.59%. Somesh?
Sir, doing, sir.
Yeah. Rajat? Rajat, are you there?
Yes, sir.
Yeah. Could you able to get the answers correctly?
Yes, sir. Yes, sir.
Right. Okay, please do that. So we're going to get 49.59% is a percentage reduction in area. And the last thing is the safe or design stress. So we know from the definition of factor of safety, which is the yield stress divided by the working stress or a design stress. So they have given factor of safety as 2 and yield stress as 260.04, what we have got here. So yield stress value. So now from this, you can easily get what is working or safe stress or design stress, which is equal to 130.02 Newton per millimeter square. So this is the final answer what you will going to get. So this carries 10 marks in your examination. Very, very simple problem and the most important problem from the examination point of view. Okay, my dear students. So please complete this problem. Okay, have it with you. Once you come to the college, I will check each and everyone's problem whether you have done or not. Okay, all the problems what I will going to do, everything should be there in your sheet of paper or a book, whatever you are maintaining. Better maintain one book, that is always been better for. Okay, because same thing will not be repeated. Be careful. So examination will be as usual. It will be going to be held. No changes in the examination, and the same thing will not be repeated once again. Be careful. Okay. So now I will stop at this point today. Let us move on to the Google Classroom for the quiz. I will assign the quiz. So please answer the quiz and submit it. Yeah, it is assigned. So please answer the quiz, and after answering, you can leave the meeting and you can join for the next class. We will meet on Friday again for the same problem, for the numerical problems only in the next class. Okay.